Alright, let's go ahead and take a look at how we can determine, based on the tableau, if a linear programming problem will have multiple solutions, an unbounded solution, or no solution. And when I say no solution here, this would be because there is no feasible region. So we also call this no feasible solution because there's no feasible region. First, if we're going to have multiple solutions, this will happen if a 0 is in the bottom row of a column for a non-basic variable. Okay, so this could be something like, let's see, say I have a column that's like 5, 3, 2, and then I hit my bottom row and I have a 0 in here. This would be an example of a column that is non-basic. A basic column would be something where we have 1, 1, and then zeros everywhere else. So a basic column or a unit column is not a problem. It's if we have a non-basic variable or a non-unit column and there's a 0 in the last row. This means that there may be another optimal solution. So what we'll do is we will use that column as the pivot column, and we'll use the ratio as we usually do to determine the pivot element. And then if when you pivot you get the same optimal value but at a different point, then this tells us that there are multiple solutions. And we saw this with the graphical method. We saw that we could have an optimal solution at 2 points, and then what happened was any point that was on the line segment that connected those optimal solutions, those were also optimal solutions. And the same thing is true here. It's just now our points might be 3 or 4 dimensional points instead of 2 dimensions. But it's the same idea. If you have multiple optimal solutions, then any point on the line that connects the optimal solutions is also an optimal solution. Okay, so we can determine that straight from the tableau itself. What about an unbounded solution? So an unbounded solution is going to happen when a pivot column has no positive entries. So this would be something like, say your bottom row is like -10, -100, and 3. And so your pivot column would be from the -100. But if every entry in that column is also negative, then you have an unbounded solution because your feasible region is going to be unbounded. So in this case, we have unbounded solutions, and so the objective function cannot have a maximum value. It is possible that we could have no feasible solution. This would occur if a tableau has a negative in the constants column. So remember, the constants column is after the vertical line, and no other entries in that row are negative. So what if we had, say, a -10 in the first row, but then our entries in row 1 are 1, 2, 3, 4. This means, remember, all of our variables are assumed to be non-negative. So x1, x2, slack1, slack2, they're all assumed to be positive. So what we have is a combination of positive things on the left-hand side equaling a negative thing on the right-hand side. And that's a contradiction. And so that tells us that we have no feasible region. So in this case, we have no solution because there is no feasible region. So we can't possibly have a solution. Okay? So let's look at some examples here. Just given a tableau, we want to determine if the linear programming problem represented by the tableau has multiple solutions, an unbounded solution, or no feasible solution. So keep in mind, the thing we're looking for, we want to look for a 0 in the bottom row. That would be 1 sign, possibly. We're looking for a pivot column that has no positive entries, or a negative in the constants column and no other entries in that row are negative. So we want to look for 0s in the bottom, pivot columns that are entirely negative, or negatives in the constants column that are also have no negatives in that row. So sort of 3 things we want to keep in mind. So first, looking at for 0s, we do have a 0, and I'm looking at this first tableau. And also, just to be clear, the constants are the -20, the 40, and the 200, and the bottom row is the objective function. Same thing for the second matrix. Okay, so you may have to draw in the lines sometimes. Okay, let's see. We do have 2 0s in the bottom row for the first tableau, but those are both in unit columns, so that's okay. So we're not going to have the first case where we have multiple solutions. So now we want to check, are there any negatives in the constants that have no negatives in that row? So take a look at row 1. We have a negative in the constants column, and there are no negatives in that row. So this tells us then that we have an unbounded solution. So we have, we have a no feasible solution. We have a negative in the constants column, and no other entries in that row are negative. So this would be no feasible solution, because we have a negative in the constants, but no negatives in that row. Let's look at the second one here. Let's see. So I usually check for the zeros first. I've got a 0, but that's okay. I have a 0, that's okay. This one, if we look at the third column, we have a 0 in the last row of a non-basic variable, so a non-basic column. So this tells us that we possibly have multiple solutions. So this is a 0 in the bottom row of a non-basic solution. And so this tells us that we possibly have multiple solutions. Now, it doesn't guarantee that we have multiple solutions, so we want to make sure that we're clear and say that it is possible that there are multiple solutions. So we can't guarantee it unless we go ahead and pivot and see if we get another optimal solution from pivoting. Now, if we were going to do that, we would pivot on this column. And so you would take the ratio just as usual. So 750 divided by 30, 30 divided by 580, 10 divided by 1 over 24, and use that to find the pivot element. So when I say pivot on that column, it's pivoting just as usual. Okay? So based on a tableau, we can determine if we're going to have no feasible solution, possibly multiple solutions, or the example that we didn't see would be unbounded solutions. But that would look exactly like we have over here. Okay? All right, that's all for now.